All right, we are looking at 2.2a still, but now we're doing part 2 because everything is better with trig. So everything we do, there's also going to be some trig parts to it. So here we go. All right, this is just some notation. This says the derivative of sine. So instead of having to write out all those words, we can use this notation. So d over dx means take the derivative of sine, that is cosine, and the derivative of cosine is negative sine. So just pay attention to that negative sign there. Okay, here we're going to go, h and I. So we're going to follow the same power down rules as we did with the first part. Okay, so I'm going to take the derivative, power down, becomes 2x, minus, but now all we have to worry about here is this cosine. The derivative of cosine is negative sine. So that's going to turn that into a plus, and the 1/2 stays exactly the same. So we don't change the 1/2, we're just changing the trig function here. The sign changed because it was a negative sign. That's it. Done. Short and sweet. Okay, let's look at this one. The derivative of 5 is 0, so we don't have to worry about that. The derivative of sine is cosine. Done. Okay, first two, pretty quick. Okay, let's go to the next one here. Find the value of the derivative at the point. All right, do not take this and plug it in here. If you do, you are just going to get 4. And we already gave you that, so don't do any extra work. The directions say take the derivative. Okay, so let's do that first. But we can't take the derivative if there's parentheses going on. So we got to eliminate those parentheses. So I'm going to FOIL this out first. Now I'm going to distribute the 4. Okay, now I'm going to take the derivative. So I did all of this just to kind of set it up. Now when I take the derivative, this 16 is nothing. This turns into negative 16. This part turns into 8x. So there's my derivative. But the directions say we want that derivative at 3, 4. So now I want this, the derivative at 3. So just put 3 in there. 24 plus a negative 16 gives me 8. Remember, this is the slope of the tangent line at that point 3, 4. Okay, so there's part A. Part B says find the equation of the tangent line. So that should be fairly quick. If I want the equation of the tangent line, that's my slope. I already know my point. So it's got to be y minus 4 is equal to 8 times x minus 3. Done. That's it. So this is part A, and that's part B. Okay, example 3. We're going to do the exact same thing. Find the equation of the tangent line. I want you to underline, highlight, circle the phrase equation of the tangent line, and write a note to yourself that that means you have to take the derivative first. Okay, so while I'm erasing this board, I want you to FOIL out what's given in example 3 there. So FOIL that out so that we can actually take the derivative. If I clean this up, that canceled right there, so I really just have x cubed minus x. All right, that's a little bit better. Now let's take the derivative of that. So there's my derivative, but I want it at 2 because I need the slope. That's 4 times 3 is 12, minus 1 is 11. That's my slope of the tangent line. The directions say what's the equation of the tangent line. So if that's the slope and that's the point, there's your equation of the tangent line. All right, there's a problem 3. The last one has 2 parts here. All right, we want to find where the function has a horizontal tangent line. So think about it for a minute. if there is a horizontal tangent line on the graph and a tangent line is the slope, doesn't the slope of that horizontal line have to be 0? So if I'm looking at this part right here, that means my slope has to be 0. Okay, so we're going to keep that in mind. So here's question A. All right, if I want the slope of the tangent line, that means I'm going to take the derivative first. So let's take the derivative here. And I got 2x. This is the slope of the tangent line. But we know that the slope of the tangent line has to be 0 because we're telling you it's a horizontal tangent line. Well, let's just go through and take that 2x and set it equal to 0. Solve that. X is 0, so you're going to take this and plug it back in here and solve it. So 0 minus 1 is a negative 1. So the spot that the horizontal tangent line is happening is 0, comma negative 1, which makes sense if you look at the graph. Here's my parabola. Isn't this the only place that there would be a horizontal tangent line going across there? And so the slope of this dotted line here is 0, and that's happening right here at the vertex of 0, negative 1, which is what we got. All right, last example here. And of course, everything's better with trig. 2 sine x. All right, take the derivative. The 2 doesn't change. Derivative of sine is cosine. Okay, so now I'm going to take that 2 cosine of x and set it equal to 0. So where does cosine equal 0? So think back to those timed quizzes. Cosine is going to equal 0 up at pi halves and down at 3 pi halves. So that means there's a horizontal tangent line at 2 spots, at pi halves and 3 pi halves. So we got to find both of them. So when you take these values, you plug them into the original. So sine of pi halves is 1. 1 times 2 is 2. Take 3 pi halves now. Plug it in here. Sine at 3 pi halves is negative 1. Negative 1 times 2 is negative 2. All right, so we got a part 1 and a part 2. Make sure you're taking a look at both and see if you have any questions for Mrs. Cook.